Hey there, ladies and gentlemen. We are going to talk specifically today, starting Unit 3 out, about writing linear equation in slope-intercept form. So we've talked about slope-intercept form. We've dabbled with it. Slope-intercept form is y equals mx plus b. M is the slope, and b is the y-intercept. And which is pretty great because the name says slope-intercept form. So it knows that you need the slope and you need the y-intercept for it. So if we look at our first few examples here, we have the slope and the y-intercept, and we are going to write our equation in slope-intercept form. So y equals negative 2x plus 5. That's all we're asked to do. If we try 2, notice that our y-intercept this time is a negative number. So you can write minus 8. You could write plus a negative 8. Now our second two examples don't say the y-intercept is a number. It says it's an ordered pair. Now we've talked multiple times in the past unit about the y-intercept as an ordered pair is represented by 0 and then the y-coordinate. And we see that on the board in Mrs. Matheson's room, so it's written there too. So we are just going to go y equals 1/2 x, and then this is just the minus 1. And our last one here, you can write 1x, or you can just have it as x. Either one of those are going to be acceptable for the solution. All right, here this is asking us to write the equation given the graph. Now in the graph we have ordered pairs, so we could use our slope formula, which again is on the wall in Mrs. Matheson's class, or since it gives us the graph, we can just go ahead and count the slope. It does not matter which direction we count. I always like to start at the lower one and count up. So up 1, 2, 3, 4. It's a positive 4. And then I'm going to the right 1, 2, 3. And so my rise is 4 and my run is 3. Now, if you would have went the opposite direction and went down 1, 2, 3, 4, we'd be down -4. And to the left 1, 2, 3, that'd be a -3. And we know that negative over negative becomes a positive. Then we're going to take a look at our graph, and we see that we have our y-intercept here, which if we look, I'm just going to move that over. Our y-intercept is going to be our -5. So now we have our slope and our y-intercept, and we can write our equation. Y equals 4/3 x minus 5. All right, I want you to pause the video here, and I want you to give this one a try on your own. And then when you come back, then we can talk about it together. So pause the video here. All right, so if you take a look here, I have your slope and your y-intercept for you, and I showed the slope in 2 different ways. One, I did not go from the point to the point with the purple. I went to the point to another point, nice point on my graph that goes through the grid lines right here. And so I went down 1 and over 2. You could have also, if you would have ended up with the 2 and the 4, one of them would have been negative, that reduces down to our -1/2. So, and our y-intercept is up at +1. So y equals -1/2 x plus 1. All right, so write an equation in slope-intercept form given the 2 points. Hint, find the slope first. So if you take a look at the wall or in previous notes, I know we wrote this at least once, our slope formula, y2 minus y1 over x2 minus x1. I almost wrote y1. All right, let's clean that up there. Y2 and minus x1. There we go. All right, so we're going to start off by labeling our points, x1, y1, x2, y2. My second point got a little out of hand, but we can do this. So we're going to plug this into our formula. 1 minus -3, make sure you put both of those, over 0 minus -2. Minus a negative is going to turn into plus a positive. So we get 4 over 2, and that's going to reduce down to 2. And so that's our m. Now, if you look at our 2 points that they give us, One of them, the second one, is 0, 1. And if you think back to our front side where we talked about those first few problems, I'll go back a couple slides here. They gave us our point, our y-intercept, as an ordered pair. And so we see the same type of thing here. They are giving us our y-intercept. So we can say y equals 2x plus 1 because that is our y-intercept. All right, we got another one here. I'm going to just jot my slope formula down. Y2 minus y1 over x2 minus x1. All right, so we're going to go ahead and put our label our points x1, y1, x2, y2, and we're going to put this into our slope formula. So 3 minus 3.5 over 0 minus negative 1. Minus a negative is going to turn to plus a positive. So 3 minus 3.5 gives me a negative 0.5 divided by 1. And 0.5 is going to be 1/2. And so 1/2, anything divided by 1 is going to be itself. So our slope is negative 1/2. The great news is here we, again, get our y-intercept as one of our given points. So we can say y equals our slope, negative 1/2 x, plus our 3, which is our y-intercept. All right, so there's our equation. We've got another one here. I'm going to jot down our slope formula for us. Y2 minus y1 over x2 minus x1. So it says 5, 7, and the origin. So you got to think about, well, what is the origin's ordered pair? Well, that is 0, 0. So that's telling me that that is my y-intercept is 0. So x1, y1, x2, y2. And now I'm going to do my slope. 0 minus 7 and 0 minus 5. So we get negative 7 over negative 5, which turns into a positive 7 over a positive 5. So now I have my slope, and I know my y-intercept is 0. So y equals 7/5 x, and then I do not write plus 0. We leave it as is. So adding plus 0 is not going to change the value, so we aren't going to add it. And if you think back to yesterday, this is a direct variation because it's a product with our variables, and 7/5 is our k value, our variable, or I mean our constant of variation. So just tying those together. All right, function notation. We talked about function notation at the end of chapter 2. Remember that it's a way to express a relationship between two variables in math. It's often written as f of x and reads f of x. So f of x can replace y equals. Now, we touched on this, that this is your x, is 2. 2 is x, but f of 2 is equivalent to y. So what that means is y is equal to 3. So this is an ordered pair 2, 3. So we're going to use that idea of function notation makes ordered pairs. So if f of x is a linear function and f of 2 equals 3 and f of 0 equals 9, find the equation for f of x. So what we have here is 2, 3 as an ordered pair and 0, 9. You should have a little alarm going off in your head. 0, 9, 0, 9. That's going to be my y-intercept. All right, so we're going to find our slope. x1, y1, x2, y2. So 9 minus 3 over 0 minus 2. 6 divided by, 2, not 3. 6 divided by 2, negative 2. Good catch, negative 2. 6 divided by negative 2 is negative 3. So that's our slope. We already talked about that this is our y-intercept. So we're going to write f of x, because that's what our function is equal to our slope, negative 3x plus 9, which is our y-intercept. All right, I want you to pause the video here and try out that next problem on your own. It's going to follow the same pattern that we just did above. All right, so take a look here. I wrote those as ordered pairs, and then I did my slope formula, so negative 18 minus 3, and then I had 0 minus negative 3, so turn that to plus to positive, and then that simplified to a slope of negative 7. We knew our y-intercept was negative 18 because it was in the ordered pair, 0, negative 18. So my function is f of x equals negative 7x minus 18. All right, so now we're on to a couple word problems. You're saving for a new pair of shoes and you already have $15 set aside. You can put $5 aside every 2 weeks. Write an equation to model the situation. All right, so we're just going to say y equals, you could use f of x, but I'm going to use y. Okay, we already have $15 set aside, and you can put $5 aside every 2 weeks. One of those is a rate, and one of those is a constant. And whatever is our rate is our slope, and our constant is our y-intercept. Well, if we already have $15, that is going to be our constant. That's our y-intercept. And the $5 every 2 weeks, that's a rate. Usually when it's like every or per, it's a rate. So y equals 5x plus 15. That's all we have to do for that situation. And there are 5 goldfish in the pond near the school. Every day, Mr. Kramer adds 1 goldfish. Oh, every day. There we go, twice. And write an equation to model the situation. So y equals, okay, he's adding 1 every day. So that's going to be 1x or just x. And there's already 5. So he's adding it to the 5 that are there. All right. That's what we got for today, ladies and gentlemen. Good luck on your work.